In this video, we'll use combination and permutation to generate the Taylor Maclaurin series sum of this function. The quantity 1 minus x to the power b raised to the power c. And the value b will be data validation, list of items 0 to 8. So our values for b will be from 0 to 8. And the value for c, so data validation, list of items 0 to 8. So these are values for c. We can choose 3 for now. Now we generate the data set, which is array formula. The quantity 1 minus x raised to the power b and raised to the power c. And we'll chart this. Insert chart, and we'll use scatter chart. And the trend line will be polynomial to the 8th degree. And use the equation as label. The legend at the bottom. So here's the trend line and the polynomial to the 8th degree. We continue with the expansion, which is the summation of a times x to the power bn, where a can be in the combination or permutation. And the value of n is from 0 to c, so this will be sequence c plus 1, c plus 1. One column starting from 0 incremented by 1. So at n equals c, then this is 1, 2, 3, 0, 1, 2, 3. And c equals 4, that's 0, 1, 2, 3, 4. Next, we continue with the permutation, which is equal to array formula of negative 1 raised to the power n times permutation c comma n. So c comma n all over factorial, that's factorial n. Yeah, so that if this is empty, this should be 0. So we'll correct this. So if c is empty, so if c is empty, then 0. Otherwise, calculate. Now it's corrected. We continue with the combination. This is array formula, minus 1 raised to the power c times combine n comma c comma n. And so if n is empty, if this is empty, this should be 0. This should be 0. So we'll correct this. So if n is empty, if n is empty, if n is empty, then 0. Now it's corrected. We can now continue with the expansion. Array formula, series sum of the x values raised to the power bn, where bn starts from 0 because n is 0, so 0, and incremented by b, and the coefficient You can choose the combination or the permutation. We go with the combination first, and their values are exactly the same. And their trend line are also the same. So we'll show the polynomial. That's series trend line polynomial to the 8th degree. For the label, use the equation. Their polynomials are the same. We'll calculate this polynomial regression coefficient using Linus. To do that, we complete the Linus matrix. So array formula of the x values raised to the power 0 to 8. Enter. Now we can use Linest. So this is equal to the Linest, starting with the function itself. That's data y and data x. We continue with the expansion. So Linest, data y, and data x. Enter. So we compare. Let's say we'll go back to 2, and this will be 2, 2 for now. Let's see if what happens. Our coefficient of x to the 0, 1. Coefficient of x, 0. Coefficient of x squared, 2 minus 2. Coefficient of x cubed, 0. X to the power 1. Suppose I'll change this to, instead of the combination, I will use permutation. Enter. Still get the same polynomial regression coefficients. The polynomials are the same. The trend lines are still collinear, and the data sets are the same. We can go with maybe 3 and increase this to 4 maybe, or 3 also. So it's easier to read. We still have the same polynomial regression coefficients, same polynomial, the trend lines are collinear, and data sets are still the same. This completes the use of combination, permutation to generate the dataset and trend line and polynomial of the expansion of this expression 1 minus x to the power b raised to the power c.